Hello and good day. Happy Friday to all. Today in Algebra, we'll be recapping what we talked about in CO17 with absolute value inequalities, and then going a little bit deeper and actually doing some examples in preparation for your test, which will be next week, since this wraps up our second unit. So yesterday we went through this first section of notes here, and just to recap this, so we'll go through it quickly. You might not need to write anything down. You might want to add some things to what you already have. But we talked about the fact that, in an absolute value equation, okay, for example, the absolute value of x equals 5, that literally means that x is 5 from 0, right? That equal sign means is, okay? Since it's absolute value, it's a distance. We have to go from 0. That's where that comes in there. But it's x is a distance of 5 from 0. So all we're changing in an inequality is just the symbol. And that's where we got yesterday that this absolute of x is less than 5 means that x is less than 5 from 0. Okay? The x is what's inside the absolute value bars. Is less than is our symbol, and then 5 from 0, that from 0 just comes from the fact that it's an absolute value. Okay? The two numbers then, I think this is a little bit different than we initially introduced it yesterday, so you might want to add this here. I don't remember if we did the graph or not. But basically, if x is less than 5 from 0, the two numbers that it can be between are -5 and +5. Right? Anything greater than -5 is going to be within 5 of 0, and anything less than +5 is going to be within 5 of 0. Anything outside of that range, anything less than -5 will be further away than 5 from 0, and anything beyond +5 will be further away than 5 from 0. So when you see that less than symbol, you know it's going to be an and statement. Okay, because that less than symbol is going to give you a range of numbers that are between two limits. And the inequality that shows this is -5 is less than x is less than 5. X is between -5 and +5, so that it is within 5 of 0. Same thing with the second one here. The absolute of x plus 4 is less than 8 means that whatever x plus 4 is, it is less than 8. And because it's an absolute value, we have to add that from 0 piece. Okay? X plus 4 is less than 8 from 0. So what two numbers can x plus 4 be between? Take a look at your notes. Just make sure you're still paying attention to me. What two numbers can x plus 4 be between? Yeah. -8 and +8. Okay? So here's 0. If x plus 4 is less than 8 from 0, that means it's between -8 and +8. Notice, again, it's an and statement. Okay, less than symbol and statement. And the inequality we can write from this to show that x plus 4 is between -8 and 8 is -8 is less than x plus 4 is less than 8. Okay? And you recognize this inequality as a compound inequality, right? You know how to solve those, because that's what we did in CO16, yes? So the goal of this first section is not solving it. We're not done here. We will still have to solve this, but you know how to do that. The goal of this top section was to get from the absolute value inequality and write it as a compound inequality, because you cannot solve an absolute value inequality the way it's written. You have to convert it, you have to manipulate it, you have to know what it means so that you can write it as a compound inequality. That's what the point of this top section is. Because once you get to this inequality here, this point, hopefully you should know how to solve that if CO16 went well for you. Okay? So when we have a greater than symbol, such as x is greater than 15, it means that x is what? How does that change things, being a greater than symbol? Blake? It's going to be an or statement, because instead of being less than 15 from 0. Being a greater than, it's going to be x is more than or further than 15 from 0. Right? X will be farther than 15. So I asked two questions here because just like our graphs above, we've got 0 and kind of that 15. What's 15 away from 0? 15 and negative 15. Instead of being between those, we're going to be further away. Less than negative 15 or greater than positive 15. We can't be both, right? It's got to be one or the other. But both those situations represent numbers that are further away than 15 from 0. So our inequality that shows this is x is less than negative 15 or x is greater than positive 15. Right? Light bulbs flickering on, fond memories of yesterday coming through, or memories anyway. Did we do the last one? Did we get that far? Yeah, okay. So for this one, same kind of thing here, right? Whatever x minus 10 is, that is going to be more than or further than 7 from 0. Okay? So what does x minus 10 have to be less than? What does it have to be greater than? Again, our number line here. 7 is kind of our range, because it's got to be further than 7 from 0. So it's less than negative 7, greater than positive 7. Our inequality that shows this, can't see my own shadow, x is less than negative 7 or x is greater than positive 7. Okay? And did we get as far as the goal, or is this where we stopped? All right, so we're picking up from yesterday. So yeah, the point of this top part is, again, we're not done, but how to write an absolute value inequality into a compound inequality that you can solve. Okay? Any questions on this before we move on? Okay. So the goal. First, we want to isolate the bars. You may remember needing to do that in CO11 also, right? We had to get the absolute value bars by themselves. You see that there are, of these 4 examples here, 2 of them, the bars are already by themselves. The second one and the fourth one, there's other stuff going on, right? In the second one, we're subtracting 6 outside the bars. We have to move that over first. In the fourth one, we're multiplying the bars by 2. Can you distribute into absolute value bars? No, you may not. So we have to move that over by division. But once the bars are by themselves, which sometimes you'll need to do other stuff and sometimes you won't, you want to rewrite as a compound inequality. Okay? Rewrite as a compound inequality, either an and statement or an or statement. And the nice thing about this is that deciding whether it's an and or an or doesn't take that much effort, because all you need to do is look at the inequality symbol itself. What I'm about to tell you is copyrighted, it's patented, you can't steal it. You can use it though. For an absolute value inequality, a less than symbol means it's an and statement. Huh? Whenever you see a less than symbol, it's always going to be a compound inequality, an and statement. On the other hand, a greater symbol will always be an or statement. Just like the 4 examples we had up above, right? Notice the top 2 are and statements for both less than symbols. Our bottom 2 are or statements for both greater symbols. You're welcome. Isn't that brilliant? No? Yeah. Thank you. Yeah. So And then, of course, to check your work, choose a value within the range and then plug it back in and see if it works. So this first one here, looking at these 4 examples. The absolute value of x plus 7 is less than or equal to 12. Our bars are already by themselves, so we don't have to do that first part. We can go ahead and rewrite this as a compound inequality. What type of statement will this be? And or? And. Less than symbol. Okay, less than symbol. If you want to, just to kind of visualize this, use the graph that we did up above. We know that x plus 7 has to be between negative 12 and positive 12. That's what this is saying. The distance of x plus 7 is less than or within 12 from 0. So the inequality we can write here, fill this in, okay, is negative 12 is less than or equal to x plus 7, which is less than or equal to 12. That inequality shows us that whatever x plus 7 is, it's within 12 of 0. It's between negative 12 and positive 12. And up above, that's as far as we got, right? We would stop here once we got the inequality. Now we have to solve it. And so go back to CO16. Think back to that. How do you solve an and statement? How do you solve an and statement? Well, right. An and statement, we are solving the whole thing at once, so it's like there are 3 parts to it. You have the left, the middle, the right. To get x by itself, we're using opposite operations. So we're going to subtract 7 to undo adding 7. That gives us x in the middle by itself. And then negative 12 minus 7 is negative 19. And positive 12 minus 7 is positive 5. Okay? So what the solution means now is that if we pick a value for x that's between negative 19 and 5, and we add 7 to it, that final value will be between negative 12 and positive 12. Okay? So our graph for this, our solution graph, just like you graphed compound inequalities in CO16, positive 5, closed circle above each of them, and you're connecting them. Okay? Peter, give me your favorite number between negative 19 and 5. Negative 18. So if we choose negative 18, which is within this range here, right? And we plug that into our original inequality, negative 18 plus 7. What's negative 18 plus 7? Negative 11, right? How far is negative 11 from 0? 11. Is 11 less than or equal to 12? Yes. Okay? That's why that's how it all fits together here, right? Any number within this range, when we add 7 to it, will be a distance less than 12 from 0. If we pick something outside the range, if we pick 8 and we plug that in here, 8 plus 7 is 15. 15 is not within 12 of 0. It doesn't work. And it's not supposed to because it's not in the range, right? Feel okay with me? At least within shouting distance? Okay. Any questions? All right. Moving on to the next one here. What type of statement will this be? And statement. Are we ready to write it yet, though? No. The bars are not by themselves. So our first step is we are going to add 6 to both sides. We can't combine 3x and negative 6 for a multitude of reasons. First of all, they're not like terms to begin with. And second of all, the 3x is inside the bars, negative 6 is outside the bars, so we can't combine them. So we're going to use opposite operations to move that negative 6 over, and we ultimately get absolute value of 3x is less than 21. Okay, which means that 3x is a distance less than 21 from 0, or 3x is within 21 of 0. So if we use our little initial graph to help us visualize that, okay, 3x is going to be somewhere within negative 21 and positive 21. That shows the numbers that are within 21 of 0. So writing this as a compound inequality, negative 21 is less than 3x, which is less than 21. 3x is between negative 21 and positive 21. Okay? As you do more of these, you'll start to kind of pick up just the format of it. Basically, and we've seen this, we saw this in the first one too, whatever's inside the bars just goes between the positive and negative value of whatever's on your solution side, right? Here we had 12, so x plus 7 went between negative 12 and positive 12. Here we have 21, so 3x just goes between negative 21 and positive 21. That's kind of the pattern with the format here, how to set these up. Yeah, Drew. Yes, you may. How do we solve this? How do we isolate x? Will? Yep, divide everything, all 3 sections, all 3 parts, divide by 3. And so now we've got negative 7 is less than x is less than positive 7. Which means that if we pick any number between negative 7 and 7, and we multiply it by 3, it's going to be between negative 21 and positive 21. Okay? So our solution graph, negative 7, positive 7, open circles, connected. Okay? Questions on that one? All right. Let's go to the third one. Okay? The absolute value of x plus 10 is greater than 15. And or, okay, greater than symbol. The bars are by themselves, so we can go straight to the compound inequality here. And what this is saying, our little graph to help us here, is that whatever x plus 10 is, it is further than or more than 15 from 0. So the inequality that we can write here is that x plus 10 is less than negative 15, or x plus 10 is greater than positive 15. Okay? As any or statements, we're going to solve this separately, right? We do that little line down the middle. You know, the inequality on the left, subtract 10, x is less than negative 25. Inequality on the right, also subtract 10, and x is greater than positive 5. So what this means is that any number that is less than negative 25 or greater than positive 5, because it can't be both, okay? But any number within those ranges, when you add 10 to it, it'll be further than 15 from 0. So our solution graph looks like this: negative 25, positive 5, open circle going left, open circle going right. Okay. Sarah, give me your favorite number that is either less than negative 25 or greater than positive 5. Negative 11 would be actually within the range that doesn't work. Less than negative 25 or greater than positive 5. Negative 28. Okay. So if we plug that in here, just so we can see it, negative 28 plus 10. Okay. Negative 28 plus 10, that gives us the absolute value of negative 18. Is negative 18 further than 15 from 0? Yes. The absolute value of negative 18 is positive 18, which is greater than 15. So it works, right? If we went with negative 11, which is not in our solution range. So hopefully this doesn't work. I'm going to be pretty embarrassed, right? But if we went with negative 11, we'd have negative 11 plus 10, which is negative 1. Is negative 1 further than 15 from 0? No, they all say in resounding unison, right? So that's how this works here, okay? Any other questions? Anything? Have I lost anybody? No longer within shouting distance? Big brain math stuff here. Okay, all right. The last one. The bars are not by themselves, so we have a little bit of extra work to do here. We cannot distribute that 2 into the absolute value bars, so instead we'll undo it by dividing by 2, right? Because 2 times the absolute value of x minus 9 divided by 2, we're undoing multiplying by 2, so it cancels out. The bars remain, though. They don't disappear like parentheses would. Parentheses are cowards. They just run and hide and disappear. Absolute value bars, they stay strong. So 20 divided by 2 gives us 10, and we have that on the right side now. So we have the absolute value of x minus 9 is greater than or equal to 10. We know it's an OR statement, greater, okay? And what this means is that, kind of our explanation graph here, the value of x minus 9, whatever it is going to be further than 10, but including 10, because it's or equal to, from 0, right? That's kind of what that inequality, or that absolute inequality, that's the graph of what we have right now. To figure out what values for x make this possible, now we write it as an OR statement. Whatever x minus 9 is, it's got to be less than or equal to negative 10, or x minus 9 has got to be greater than or equal to, oh, I made it, positive 10. Okay? And again, with the OR statements, it's not as easy to see, but there's a connection here. There's a format pattern. From our original inequality, that x minus 9 doesn't change. We take the bars off, right? But it's still x minus 9. That positive 10 just becomes less than or equal to the negative value of it, greater than or equal to the positive value of it. We saw the same thing here, right? 15 less than negative, greater than positive, and what was inside our bars, x plus 10, didn't change. So there's a format pattern for the OR statements too, and there it is. So to solve this, we would add 9 to both sides here. Negative 10 plus 9, x is less than negative 1, or positive 10 plus 9, x is greater than or equal to positive 19. So any number within those ranges, less than or equal to negative 1 or greater than or equal to 19, will make this inequality work. Our solution graph, which is the graph you actually need to have, that first graph is just kind of a helpful visual, perhaps. Okay? Less than or equal to negative 1, greater than or equal to 19. Give me your favorite number that is in one of those ranges. John. 13 is in between. 21, right? If we take 21 and we go back to our original inequality, which is 2 times the absolute value of 21 minus 9, well, 21 minus 9 gives us 12. The absolute value of 12 equals 12. We multiply that by 2, and we get 24. And 24 is greater than or equal to 20. It is further away than 20 from 0. All right? Who misses when math was this? N plus 1 equals 3. Solve for n, right?
When it was like now 7 1,000 times.
Yeah, the thing about pre-algebra, which again you essentially skipped that class. You actually got a lot of pre-algebra last year in 6th grade. Mrs. Fimon does a fantastic job, but you skip the bulk of it. K5 math is all really just the same thing. Once you get the 4 operations down and you understand fractions and decimals, it's really just repetition over and over and over again, right? As soon as you hit that algebra stuff, there's so much you can do with those operations, which is why it's important to know them because you use them constantly. I mean, this is, whoo, look at that work, right? Great stuff. Hey? Great stuff. Any questions on this side before we flip over to the back? Okay. I'm still on the, where did I put my pen? There we go. Oh, clearly again. Your homework then for Monday. I'd like you to do the second page, but not all of them. These first 6 for sure. Notice that you might want to write in now which ones are and which ones are or, since that is still fresh in your mind. There are 3 of them where the bars are not by themselves, the 3 in the second row. So you'll need to do that first. Okay, use opposite operations to get the bars by themselves before you go into your compound inequality. As with any inequality, when you are solving it, if you run into multiplying or dividing by a negative number, which looking at this, I see you will run into that twice, you do need to flip your sign. Okay, just keep that in mind as well. And then after these 6, well, let's see, what kind of mood am I in? What am I looking for here? I want you to do this one. So what value for n is a solution to both the absolute of n minus 2 is less than 1 and the absolute of n plus 6 is greater than 7? It seems like it might be pretty challenging right off the surface, but basically all you're doing is if you solve this inequality and you get your graph, and then you solve this inequality and you get your graph, you're looking for where those graphs overlap. Right? So what's a number that would be a solution to both, meaning when you graph those on a number line, where are those graphs going to overlap? So you might want to, when you graph these, graph the first one, like right there, graph the second one above it, so you can see where they overlap. What numbers are a solution to both graphs, meaning it's a solution to both inequalities. Okay, so it's really no different from the top 6 and everything that we've done. You're just now looking at 2 graphs at once and looking for values that are solution to both, where they overlap. Okay, I'm not going to have you do the second one, so no for that one. Well, I got to see what's on here. Hold on, I forget year after year. Ooh, that's hefty. Let's see.
6 and then add in that one.
Since you have your practice test also over the weekend, I will nix these other 4 as well. So just really the first 7 on the second page, the 6 that you need to do, the algebraic ones, and the first brain buster are all that's going to have for your homework, and then the practice test also. Okay? Any questions, comments, concerns, complaints, compliments, or criticisms? My day's fine, thanks. For what? Thank you.
I like your badge.
I like your face. All right, that's all your math.